Our 10th problem for anionic equilibrium is an easy problem. We need to find the pH of 1 molar acetic acid, and in the second part we need to find to what volume must 1 liter of this solution be diluted so that the pH of the resultant solution is equal to twice of the initial pH, and we are given with the data the dissociation constant for the acid to be equal to 1.8 into 10 power minus 5. Now CH3CO2H, as you can see, has one ionizable H, but you cannot directly say that the concentration of acetic acid is equal to the concentration of hydrogen ion, because acetic acid being a weak acid and having a low dissociation constant, as you can see from the dissociation constant value, only a small amount of H plus ion concentration will be formed. Let us consider the reaction CH3CO2H dissociating into CH3CO2 negative plus H plus. Let the initial concentration be C. If it dissociates with a dissociation constant, or the degree of dissociation, let it be alpha. So after a certain time period, this becomes C into 1 minus alpha, this becomes C alpha, and this becomes C alpha. So for this reaction we can write the value of Ka to be equal to C square alpha square upon C into 1 minus alpha, and this is given to be equal to 1.8 into 10 power minus 5. This becomes C alpha square upon 1 minus alpha is equal to 1.8 into 10 power minus 5. Now we can see that the dissociation of acetic acid is very less, seeing the value of dissociation constant. Hence we can say that 1 minus alpha is approximately equal to 1, being the degree of dissociation very small. Hence we get C alpha square is equal to 1.8 into 10 power minus 5. Since it is given 1 molar acetic acid, so this C is equal to 1. So alpha square is equal to 18 into 10 power minus 6, which gives the value of alpha to be equal to 4.24 into 10 power minus 3. You can very clearly see that the degree of dissociation of acetic acid comes out to be very small value. Now from this reaction we can see that the H plus ion concentration is C alpha, that is alpha since C is 1, and alpha is 4.24 into 10 power minus 3. This is the H plus ion concentration. Hence our pH will be equal to minus log of 4.24 into 10 power minus 3, and this is equal to 2.3724. Hence our pH for 1 molar acetic acid comes out to be equal to 2.3724, which is the answer of our first part. Now in order to find the answer for the second part, we are asked that to what volume this 1 liter of the solution be diluted so the final pH is equal to twice of the original pH. So our final pH will be equal to twice of this pH, that is twice of 2.3724, which is equal to 4.7448, minus log of H plus ion concentration final is equal to 4.7448. From here we can find out the H plus ion concentration in the final solution. Let the final concentration be C1 and the dissociation constant at that time it to be equal to alpha 1. So this becomes C1 into alpha 1 is the concentration of hydrogen ion finally, and this is equal to 10 power minus 4.7448, which comes out to be equal to 1.8 into 10 power minus 5. Now our Ka is equal to C1, writing the equation again, CH3CO2H giving CH3CO2 negative plus H plus, this is C1 square alpha 1 square divided by C1 1 minus alpha 1, and this is equal to 1.8 into 10 power minus 5. since the value of Ka is given to be equal to 1.8 into 10 power minus 5, this C1 and C1 gets cancelled. We know the value of C1 alpha 1 to be equal to 1.8 into 10 power minus 5. So this can be written as C1 alpha 1 into alpha 1. So this can be written as 1.8 into 10 power minus 5 into alpha 1 upon 1 minus alpha 1. This gets cancelled. Hence we get alpha 1 is equal to 1 minus alpha 1. Hence alpha 1 is equal to half. So when the solution is diluted to twice of, so that the final pH is twice of the original pH, we get the degree of dissociation of acetic acid at that time to be equal to half, which gives C1 to be equal to 3.6 into 10 power minus 5. We need to find the final volume. Hence we can use the formula M1V1 is equal to M2V2. Initially it was 1 molar acetic acid, the volume was 1. Finally the concentration comes out to be equal to 2.3724, and we need to find the final volume. So on solving this, the final volume comes out to be equal to 2.77 into 10 power 4 liters. So our final answers are, the pH of 1 molar acetic acid comes out to be equal to 2.3724, and the final volume to which the solution to be should be diluted so that the pH becomes twice of the original pH is equal to, the volume is 2.77 into 10 power 4 liters, and these two are our final answers.